Not quite sure why I said hello like that, but that's how I chose to say hello this morning. So, what are we going to do this afternoon? We are here in the secondary live lesson. We are here for anyone from years 7 to 11, but you're welcome if you're year 5 and 6. Just don't worry if it's too difficult. I'm going to do my best to teach you about the equation of a straight line. Hopefully Sophie is joining us, because Sophie has requested this one. I'm going to do my best to teach you about gradient and y-intercept. I'm going to teach you how to find the equation of a line and how to use that line to draw the graph of the line itself. I'm also going to show you how, if you've got two coordinates, you can also find the equation of the line. And that is what we're going to do today. I'm back! So, what we're going to talk about? Well, a straight line. Here's my arm. It's not the best straight line, so I've been using my drumstick. That's why in the thumbnail I've got a little drumstick. Straight lines can be that way or that way. And they go on forever. So the equations we're going to talk about today, it's not just that bit. It carries on all the way down there. I wish I had some clever graphics. I could just do that and it just followed my finger. And all that. I know what I can do. I can just put it there and it just is in the way of everything. But a straight line equation is going to be the equation that describes that line. The reason these lines exist is because you always have an input and an output, an x and y value, and coordinates are an input and an output when something happens. So the coordinate 2, 2 is not just a coordinate, it's not just a point. It is when I put an input of 2, I get an output of 2. So there's been a machine that's taking place. And lines are specific machines where whenever you do something, you put the input in, it does that same machine to the value and gives you a new output. Let's head over to my slides and we'll see what I'm talking about. So, we're going to be talking about this. This is a couple of challenges that people have done so far. I love seeing people attempting the Taskmaster challenges. These guys are the best. Willow has come up with some excellent things and she's winning every challenge at the moment because not enough people are trying them. Even if you're not watching it live, please still, if you're watching it in the same week as the challenges, if you get these responses to me, I will try and each Monday try and show clips of people's efforts at the different challenges. There's always a Taskmaster challenge. I'm always going to try and give you different interesting things to do, especially over Easter. So pay attention to the challenges at the end and I'd love to see what people are coming up with. So what we're going to learn today, we're going to learn about gradient and y-intercept, the equation of a line, the equation from coordinates, and then there's some keywords to make sure we know. Gradient, y-intercept, equation and linear. And you can see they met the cyclist on a steep slope. The reason we're doing that is because that's to remind us what a gradient is. It's how steep the line is. Don't forget, when you do any of the work that's referenced here, please send me pictures, send me stuff on the Facebook group. The more stuff you send me, I can do two things. One, I can publish your stuff and you can be featuring the video and you can become famous. I think we've only got about 1,100 subscribers at the moment, but that's our own little version of famous among our little community. But also, it allows me to answer questions. If you post comments in the YouTube videos, that I can respond to. I'll happily answer questions if there's anything that doesn't make sense to you as we're going along. Especially if you spot any errors. Sometimes I make mistakes. We all do. So hello, gradient and y-intercept. In order to show fully how we're going to do the gradient and y-intercept, it's going to be necessary for me to go to my whiteboard, because the whiteboard is the best place to demonstrate what's going down. And in order to do that, we are going to start over here, right about now. Hello! So we have got an equation. The equation could be something like this. Y equals 3x plus 2. Now, if this doesn't work, I'll correct the x. Sometimes it doesn't work like the way I do my x's, which are the correct ways, but we will hopefully forget. No, it doesn't like the x. Do not fear. We'll quickly rub out that x, replace it with the annoying x that I try and tell all my students never to draw, because it looks like a kiss or a times symbol. But if I click that, it does like it. I can then click plot in 2D And I can insert this graph, and we've got this graph. What this shows is there's key features. First one, this cuts the graph at 2. That's what the number bit tells us. Now, what is going on here? Well, what's going on is there's an input and an output. So when we put in the number 1, when x is 1, we go 3 times 1 is 3 plus 2. The output is 5. The second number is the output. So 1, 5 is on the line. And you can test any number. We could test, is 3, 11 on the line? Well, we got an x and a y. I'm going to make it a proper coordinate. So we're going to put 3 times 3 plus 2. That's 9 plus 2 is 11. Yes. So it is on the line. I will say hello to anyone who's in the live chat. I can see there's a few people. There might be some people writing questions and things. I'm just going to do this brief introduction. We're going to talk about y-intercept and gradient. Now, the gradient is how steep the line is. And that is a measure of every step we go across 1, how many squares does it go up? And in this case, it's 3, which is where the number before the x comes from. This is the gradient. Now, we call the other number the y-intercept because it's the place where the y-axis is cut through by the line. So it intercepts it. In football or netball or hockey or rugby, an interception is where the ball is cut out. Well, in the graph, an intercept is where the line gets cut, the y-axis gets cut out or cut through by our line. So we've got the number and the number before the x. That gives you the gradient and the y-intercept. You can always find the gradient, if I just clear this up a bit and make it cleaner, by doing the rise over the run. What that means is you find a whole number, here's 1, and you find another corner that it goes through, and we go across 2, up 1, 2, 3, 4, 5, 6. So you don't have to be along 1. If it goes along 2, you can count it goes up 6. The gradient is always going to be the rise, how many it goes up, divided by the run, how many it goes along. So in this case, it's 6 over 2 equals 3. But if we've got the equation, the gradient is always the number before the x, and the y-intercept is always the number on its own. That can be confusing, and I've deliberately put one that's confusing in the questions we're about to do. So we're going to fly back to our PowerPoint, and when we get there, we've got some questions to try. As I often do when we do our first 4 questions, write them down, write what you think the answers are. If you're not doing this live, feel free to pause the video, write down what you think the answers are. The answers will be shown in a second. If you're doing it live, I'm going to give you a few seconds just while I say hello to some people in the chat. Hello, Nina. Hello, Willow. Hello, Amber. Hello to Orla. Good afternoon, anyone else? Alicia's here again. Hello, Lars. Good morning. Hello, Amber. I possibly said hello to everyone now who's using the chat. Feel free to use the live chat if you're here. There are 11 of us so far. Hello, Janine. I'm never sure whether it's actually Janine or whether there's someone working under Janine's name. So, how are we getting on with this? Let's have a look. The first one. The gradient is 3 because it's the number before the x, and the y-intercept is 4. Now, you'll notice all these questions are questions A. I'm a bit of a rebel. Probably a bit good idea to get out the way of the questions, isn't it? I'm a bit of a rebel. I don't always like to subscribe to A, B, C, D. So I've decided that today we're going to have question A, question A, question A, and question A. So the answer to question A is the gradient is 2, the y-intercept is -9. And the answer to the next question A is the gradient is 1/2. X over 2 is the same as 1/2 because there's a secret 1 before the x. So anytime you see a no number at all, that's a 1. So if you've got x over 2, that's a half, and the y-intercept 3. And this is what the last one is sent to try and trap people. Question A. The answer is the gradient is -2 and the y-intercept is 7. I switched them round just to get you, because the number is the y-intercept, and the number, we call it the coefficient of the x. The number that comes before the x is -2. Notice how in question A and in question A, the minus numbers belong to the numbers that come after them. So it's -9 and it is -2 is the gradient of A. So let's go forwards, and I'll reappear on the screen, and we'll talk about how we can therefore use all this fact, the gradient and the y-intercepts, to find the equations of some lines. And in order to do so, here's one I prepared earlier. If I go to equation of a line, I can find all these equations. And I'm going to hide this. And we, because of what I'm about to teach you, are going to find the equations of all these lines. And to help us, I'm going to move this over out of the way so I'm not in the way, because you want to be able to see my silly head. So we've got the first equation. Checking everyone's with me. We've got hello Willow and Willow's sis and bro. We've got that cuts through at 4. So we know it's going to be y equals something x plus 4. Then we're going to find that one goes along 1 up 3. 1, 3, so the gradient must be 3x plus 4. And then, just like you or I, they need their names along them. So we write them along the line. Y equals 3x plus 4. That's the first one done. That is how we find the equation of that line. It's not that much more. It doesn't get much harder than that. Let me show you again with a different colour. Purple. This one, it cuts through at 5. So we know we're going to need y equals something x plus 5. If I go along 1, it only goes up 2 this time. So the gradient is just 2. So it must be y equals 2x plus 5. This is how we find these equations. We're just finding the y-intercept and the gradient. All we're saying is that this line is represented by inputs of x and outputs of y, and we can draw the line. Well, what about this one? I can hear you all ask. This one cuts at 0, so there's a trick. Y equals something x, and we don't bother writing plus 0, just going to leave it as something x. But then from here, look, 1, I'm just going to show you how we can use the gradient for a bigger gap. Goes along 3, up 3. So it's the rise divided by the run is 3 over 3, which is 1, which tells us, if that is on the screen, I haven't even checked. Oh, good grief, why are we not with me? I've been doing this and you couldn't see it. Sorry Nina, sorry Ola, sorry Amber. I am getting better at this, but every now and again, the computer doesn't do what I tell it to. So I'm going to go back through these. The green one I did was, it cut through at 4, so I put a 4. Then I went along 1, up 3, so that tells me it was 3x plus 4. The purple one, it cut through at 5, which gave me the 5, and then went along 1, up 2, so it must be 2x. The next one, I've got cut through at 0, so I didn't put a value, but it goes along 3, up 3, which means I've got along 3, up 3, divides by 0 equals 1 is the gradient, so we don't even need to write 1x. I'm going to, but we can just put x. So this one I'd probably write y equals x, and that's what I would write as the equation there, because 1x is the same as x. This next one in orange, we've got -1, so y equals something x minus 1. But we're going to choose a point, and we're going to choose another point, and go along 1, up 3. So it must be 3, so it'd be 3x minus 1. Now you may spot this. I don't know if you can see it on your things or not. This line has 3x, and this line has 3x. And notice these lines are parallel to each other. That's what happens when you get two lines that have the same gradient. When they have the same gradient, they are parallel. So that because they're both 3x, they end up both being parallel to each other. The last two change it up slightly. They've got a 6, but this time when you go along 3, you go down 3. So that's a -3. So when we're doing the gradient, you're going to do how much it is up divided by how much it is along, but the up is -3 because it's actually down. Divided by 3 is -1. So this one is y equals -1x plus 6 there. And this one goes through 2, but we've also got a long one down 3. If it goes along 1 down 3, it must have a gradient of -3. It goes along 1 down 3, so we end up with y equals -3x, and it crosses at 2, so it's +2. All of them trying to point out to you the gradient, the gradient, the gradient, the gradient, the gradient, the gradient. They are always how steep the line is. The bigger the number, the steeper the line. Okay. Okay, hopefully that's helping. Yeah, hopefully you can all see that now. I think I've removed the video because I don't get to see the video. It's not you. Start again. The video screen I'm looking at hasn't got me on it. I'm on the screen that you can see, but I'm not on my screen, which is why sometimes I don't know that I'm in the way. That's why I do apologise when I mess up. Hopefully that makes sense so far. So, what we've said there is that if you know the line, you can work out the equation. Now the same would be true if you know the equation. What you do is you draw the y-intercept. It's called the gradient y-intercept method. You draw the y-intercept, go along 1 and go up or down however much the gradient is. So if I wanted to draw a new graph, I can do that as well, because all I have to do is take the gradient and the y-intercept and I'll be able to do it. Just to show you what that means. If I'm asked to draw y equals 2x plus 4, here is my y equals 2x plus 4 and I've written it down. The first thing I'm going to do is go to 4. I'm not even going to write the whole scale out. I'm going to go to 4, and then I'm going to go along 1, up 2, to 6. That tells me where the next point's going to go. So what I've done is I've got the first point as the y-intercept here, and I've got a long 1, up 2. So if I get my ruler, obviously I'm using my invisible ruler, I can draw the equation like that. So hopefully that's now visible for you all. Right. We have one more layer to go. What about if it gives you coordinates to work with? And there's two levels, A and B and A and B. As I've said to you before, I got a little bit fed up with being A, B, C, D, E, so we've got A and B and A and B. A and B, these ones, they give you, this first one is 0, 5. Remember, 0, 5, let's move them over just in case we get any complaints. We can't see it, sir, because your silly big head is in the way. Which is a reasonable complaint, to be fair. So, here we've got, this is 0, 5, so it's no different from just saying 5 here. 0, 5 is 5. But then, how I do it, I do a little triangle, and it's gone from 0, 5 to 3, 11. So the 0 has gone to 3, and the 5 has gone to 11. So I think that's a change of 3 and a change of 6. So the gradient equals 6 over 3 equals 2. So this is y equals 2x plus 5, because it's going through at 5. Let's do another one. I'll try and use a thinner line this time, because this was quite a fat line. You're calling me fat? Yes, I am. Oh, I'm not going to let you draw me anymore. Right, this one, 0, 5. 0, that's not even 0, 5, that's 0, 3. So that's a 3. And this one is 2, 17. So that's a 17. And that one's a 0. And that one's a 2. I hope you all agree that going from 0 to 2 is a gap of 2. And going from 3 to 17 is a gap of 14. Therefore, the gradient is 14 over 2. Remember, it's always how far up divided by how far along. So we then get the gradient is 7. So it's y equals 7x plus 3. So we've done those two together. Oh, I've done it again. Mr. Harris, stop doing this. You're in the way all the time. I reckon what I need to do is someone needs to be like have a button that they can press. Like Lars has an electric button he can press so he can buzz me so that I'm not in the way. So what I did here, let's just rub this bit out. What I did was I said, well, that's 0, 5, so that's at 5, and that's 3, 11, so it's at 11. So it's gone from 0 to 3, so that's why the dotted line goes along 3. And this has gone from 5 to 6, which is why the dotted line goes up 6. Which is why we've got 6 over 3 is 2x plus 5. And this one goes from 0 to 2, which is where the 2 comes from, and it goes up from 3 to 17, which is where the 14 comes from. So we've got 14 over 2, which is 7, which is where we got y equals 7x plus 3. You're with me? Yes, that's a brilliant pun. That is one of my favourite puns I've seen in a long time. I'm going to drink to that, Nina. The we can't sequel. Amazing. Amazing. We're going to learn, by the end of the summer, I'm going to do at least one lesson where you can hear me the whole lesson, where you can see me the whole lesson, where you can actually learn the whole lesson. But I'm an old man. I'm still learning this technology. This one here is a bit different because we don't have this number here. We don't know exactly what that number is, but we can find it. And here's how. First thing we do, that is minus 3 and that's 3. That is 2 and that's 8. So I think it's going to go along 6 and up 6. So the first thing we've got is if it's along 6, up 6, the gradient is 6 over 6, which is 1. Hopefully you're all clear why the gradient is 1. So we know it's y equals 1x plus something. The way we then do this is we take one of these points, and I normally take the positive, this one, because I think it's easier to work with the positive one. And I write the following statement. At 3, 8, we swap the numbers in. 8 equals 1 times 3 plus question mark. So the question mark must equal, 8 is equal to 3 plus something, it must equal 5. So that's how we know that it's y equals 1x plus 5 or y equals x plus 5. Y equals x plus 5. Let's go through that shenanigans again. This is the level 9, 10 type stuff. It's okay if you're struggling, especially for people like who are year 5s and 6s who are still joining us because they're very, very brave. Okay, here I've got 2 points. It goes from 1 to 3 and it goes from 13 up to 19. So here's the triangle. 2 by 6. So the gradient is 6 over 2, which is 3. So we know y equals 3x plus question mark. So again, we now are going to use a point that we know. At 113, because we can see that's on the line. Remember, we've got an x value and a y value. 13 is the y value, equals 3 times 1 plus question mark. 3 times 1 is 3, so I think the question mark must be 10, which tells us y equals 3x plus 10. Y equals 3x plus 10. So that is how we do it when we know coordinates that aren't on the line. That's harder there, it's a higher level, but What I always try to do with the secondary lessons is go through a whole range of difficulties. We've got a whole load of different people here, and so I need to try and make sure there's something to learn for everyone and not just a few bits. So, let's head back to the studio. Make sure you can see the studio, because if you can't see my lovely face. We have looked at the gradients of y-interceptors. We've looked... That's not even a phrase. I'm going to stick with it. Equation of a line. Found the equation. And we found the line from the coordinates. You can always rewind and go back to anything you're trying to do. So my challenge... There's a worksheet should be in the description. Please tell me if it's not there. I think I put it there. It's a link to an equation from a place called Math Genie. And it's loads of stuff to do with the stuff I've taught you today. The answers are available on that website as well, so you can actually look at that website and find the answers. So it's on Math Genie. If you go to that link, it should have a question sheet and some answers, so you can find the answers for yourself. And today, your Taskmaster Challenge, and it's only going to be fun. I love this if people take part. You need to actually let me know your new word. Invent a new word. It can't be currently used for anything. If I look up your new word, it can't be currently in use. So maybe Google it and check whether it's a new word. It must have a clear meaning, and the best new meaning and word wins. I reckon Lars will do quite well at this because he's good at coming up with random stuff. So send me an email or send me a picture. I'm in the way again. I'm going to spend the afternoon learning how not to be in the way by hiding in my office so that my wife doesn't think I'm in the way all the time. I am going to try and practice removing myself so that I'm not in the way. Here's the maths challenge. Here is the Taskmaster challenge. And so do your best and let me know if you've learned anything today. You may decide you don't want to like the video today because I was in the way so much. That's absolutely fine. I will understand. But if you did like it, do consider subscribing if you haven't subscribed already. If you're watching this later, share it to people you think might enjoy it, might learn something from it. Hopefully it's been useful. I've been Mr. Harris, and I'm going to head off into the sunshine. Au revoir.